Good morning, Year 12 Further Mathematicians. Just going to go through question 12 from the Further Maths Internal Exam, Paper 2. We've got an inverted cone with water inside the cone. The volume of the water is V meters cubed. We're told the radius at the top is 3 meters. The total height of the cone is 5 meters. The height of the water inside the cone is an unknown variable, h meters. And water is leaking out of the bottom of this cone at a constant rate of 0.02 meters cubed per second. And they give us a little bit of a clue. At some point we might need to calculate the volume, which is V equals 1/3 pi r squared h for a cone. Now the first thing I would do is rewrite this sentence in just mathematical symbols. So if this particular object is leaking water, then the thing that is at a constant rate, that's in effect saying dV by dt is equal to, now because it's leaking, the change in volume with respect to time is decreasing. It is decreasing. So it's a negative 0.02. Now the clue on why it's dV by dt is in the units there. Meters cubed per second. Meters cubed is a volume, per second is time. So that is why I chose dV by dt is equal to negative 0.02. And the negative is because it is leaking. Now that's all that's given in the question, and then you are asked to work out dH by dt effectively. Now this is called connected rates of change because you've got a chain rule in differentiation which allows you to write stuff like dH by dt in terms of stuff like dV by dt. So the first thing I'm going to do is focus on the dH by dt. And the letters which have been used are V, T and H. Now, how else could I rewrite dH by dt? Well, in terms of V's, T's and H's, it could be dH by dV times dV by dt. And that is the chain rule. And that is the connected rates of change in this question. Now, dH by dt is unknown. But dH by dV, now you can't work out, or you could, but it'll take a few more steps to do this. You can't really work out dH by dV easily, but you can work out, based on this formula, dV by dH, the reciprocal of it. So if you differentiated this with respect to h, okay, now I've just realised that I've got to do one extra thing before I actually attempt to differentiate, because 1/3 is a constant, just a number, pi is a number, but r squared is something which does change as h varies. And you need to find out what that change is. Now, that's r there. And the one way to do this is use the fact that all cones are similar objects. So this cone there is similar to this cone there at the top. So if I wanted to work out the actual radius for this, one thing I can do is remember that the ratio between the radius at the top for the big cone and the radius of the small cone is exactly the same as the ratio of the height of the big cone and the height of the small cone. In other words, the big radius over the little radius needs to be equal to the big height over the little height, and if you make the little height the subject, you get r in terms of h. So r would be times by r times by h and divide by 5, it'd be 3/5 h. So that's actually a really key thing to do, because r was a variable, but you needed it in terms of h, and you needed to use similar objects. So in other words, this formula for volume is actually 1/3 pi, radius is 3/5 h squared h, which is the same as, if you expanded that, you would get 3/25 pi h cubed. I believe if you expanded that, and then we can work out dv by dh, and dv by dh would be 9/25 pi h squared. Differentiating this now, you just times by the power, knocking off the power. Right, finally we've got dv by dh, but dh by dv is that flipped, so we need to take the reciprocal of that. So that would become, if we wrote it over one giant fraction, everything over 25, it'd be 25 over 9 pi h squared times dv by dt, which was given in the question, -0.02. And if I compare this with what they want me to get at the top, the only thing they've done is times by the denominator h squared. So that's what I'm going to do next, times by h squared, and I get h squared dh by dt is equal to 25 over 9 pi times -0.02, and times this on my calculator. So all I'm going to do is times the fraction and the decimal, knowing that pi is going to be on the denominator anyway. So 25 over 9 times -0.02 is -1/18. So you get h squared dh by dt is equal to -1/18 pi as required. Tough part A, that one. Right, part B is, given that the container is initially full of water, express h in terms of t. So in other words, solve. Okay, so solve this. But they give you an initial condition. They tell you that it's full when t is equal to 0. So full when t is equal to 0. Now what would the volume be, or the height be, when t is equal to 0? That height would be 5. So in other words, the height is equal to 5. Now let's actually solve that differential equation above. So this is a separable differential equation, and they've already separated it for you. So you would just integrate with respect to t, knowing that these cancel, and you're left with 1/3 h cubed is equal to -1/18 pi t plus c. And then you can work out the plus c using that initial condition. When t is equal to 0, h is equal to 5, which means 1/3 5 cubed is equal to 0 plus c, to give you c is equal to 125 over 3. So we have, the initial formula is 1/3 h cubed equals -1/18 pi t plus 125 over 3. and they want h as the subject, so you'd effectively times by 3 and cube root. So let's quickly do that. Times by 3 and cube root. The 18th would drop down to a 6th, so minus 6 pi t. 3 there would disappear, 125, and you got cube root in everything. Like so. Part C. Find the time taken for the container to empty, giving your answer to the nearest minute. So there are many ways to do this. Because it's leaking out at a constant rate, you could use the volume. Or the alternative is, now, if you're confident with this answer, you can just substitute h is equal to 0 in when the height drops down to 0. That would be when it's empty. So let's do both methods. So let's make h equal to 0. If h was equal to 0, then effectively inside the square root is equal to 0, or the cube root, sorry. So you'd get a 16th pi minus 1 over 16 pi t plus 125 is equal to 0. If you make t the subject, okay, just corrected a mistake, that would have been a 6 there. And now if you do 125 divided by 1/6 pi, you get that, which is 2,356 seconds, which is equivalent to 39 minutes. There is an alternative to this, is considering the volume instead of the height, because the volume is escaping at the same rate. If you knew the initial volume, you could work out how long it took for the entire volume to escape. So the initial volume would be 1/3 times pi times the radius squared times by the height. So that's the volume at the start, and it leaks at a constant rate of 0.02. If it wasn't constant, I could not do this to give me the same answer. And the same answer in minutes, obviously. And that would be it.